Good afternoon, everyone. Welcome to Science with Mama J. This afternoon, we're going to talk about some concepts to help prepare for the Science 8 exam. So, this exam is focusing on forces in motion and waves and energy. So, we're going to be focusing on forces here and talking about the different types of forces that you've looked at this entire semester. So, we have first, to define a force is the difference, is either a push or a pull. So you have two different types of forces: contact forces and non-contact forces. So a contact force would be coming in touch with an object, whether you're pushing it, whether you're kicking it. So frictional forces, pushing, pulling, all of those are contact forces. Okay, non-contact forces, electricity, magnetism, and gravity. Those are the three big ones. Here you have pushing or pulling, which would include friction. Okay, and we're going to start with that. We don't want to include too much in this right now. So I'm just looking at the benchmarks that I had to pull up for you. So when we're looking at, for example, some of the non-contact forces, one of the ones that I wanted to focus on was gravity. Gravitational forces are responsible for many things, both on Earth and in the solar system. In the solar system, it is mainly responsible for actually pulling planetary objects together and keeping planetary objects in alignment. And when we look at gravity, two things affect gravity: mass and distance. So the closer you are, the greater the gravitational pull between the objects. The further away you are, the lower the gravitational pull between the objects. As far as mass, the greater the mass, the greater the gravitational pull. The lower the mass, the lower the gravitational pull. So the least gravitational pull would occur with something with a small mass that is very far away. And the greatest gravitational pull would occur with something that has a larger mass that is very close. When we look at forces, we look at speed. Speed is one of the forces that you discuss in class. Speed is equal to distance over time. Okay, so you do have to understand this formula. So when you're, for example, an object that is moving, that moves 12 meters in 6 seconds, that object is moving 2 meters per second, because 12 divided by 2 is 6. Make sure you keep track of your units. Units are very important. Okay, one thing that we do need to focus on, a lot of people struggled with this, was weight and mass. The difference between weight and mass. An object's mass is universal throughout. So if I were to take an object, for example, if I were to take this marker and I were to take its mass on Earth, its mass would be the same on Earth, on Mars, on Jupiter, on Pluto, in another galaxy. The mass would never ever change. But weight is the gravitational pull of an object times its mass. So weight is gravity times mass. Okay? So the weight of an object is 9.8. Well, on Earth, it is 9.8 meters per second times the mass. And the mass, so it will change based on what it is exposed to. So for example, if you have an object on Earth, it's going to be 9.8 times the mass. If you have an object on the moon, well, the moon's gravitational pull is 1/6 that of the Earth. So if an object, for example, and I'm going to use pounds here, if an object, for example, weighed 180 pounds on Earth, it's only going to weigh 30 pounds on the moon. And because the gravitational pull of the moon is 1/6 that of the Earth. So, balanced and unbalanced forces. When we talk about balanced and unbalanced forces, okay, a balanced force is a force that is receiving an equal force from all directions, so the net force would be 0. For example, if I have an object that is being pulled in this direction and pulled in this direction, if it is pulled at a force of 10 newtons here and a force of -10 newtons here, well, -10 plus 10 is equal to 0. So this force is balanced. But if I have an object that is being pulled and it is being pulled by a force of 10 newtons in this direction and a force of 5 newtons in this direction, then -5 plus 10 is equal to 5 newtons to the right. Now, these negative signs that I have here, they depict the direction of a force. So, to the right and up, these are going to be positive forces. To the left and down, these are going to be negative forces. So if you see a force pulling down, you're going to depict it in a negative direction. If it's pulling to the left, you're going to depict it with a negative direction. Here, it's going to be positive if it's going to the right or up. So that just helps you with adding the forces like we did here. So you would add up all of the forces. And in this case, this force is unbalanced. Okay, now sometimes you'll have something that's a little bit more complex. Okay, for example, you have a force that is on a table. Okay, so they will give you a table and you have a box that is on that table. And they show you a force going this way, a force going this way, a force going this way, and a force going this way. And let's say you have a person pulling this. Okay, so if a person is pulling it that way, well then this force is the frictional force. This force is the gravitational force. And this force here, that is the force that the table is applying to the object. Okay, so this is the table on the object. Okay, yes, the table is not moving, but if the table was not applying a force on the object, then the object would actually collapse the table. Think about putting a bowling ball on a pillow. If you put a bowling ball on a hard table, the bowling ball may roll a little bit, but it's going to stay on the table and the table is going to stay upright. But if you were to take that bowling ball and place it on a pillow, it's going to collapse the pillow because the bowling ball is placing more force on the pillow than the pillow is placing on the bowling ball. So you're going to have a collapse. So here, in order for this table not to buckle, it has to place an equal and opposite force than the gravitational pull is placing on the object this way. Now, this frictional force is generated right here. So as you're pulling the object, okay, the difficulty of pulling the object is going to depend on how much friction is operating under this box. And that frictional force is going in the opposite direction that that box is moving. So that's pretty much what we had to cover in terms of forces for now. I also have a few other videos that help go over forces that I will tag for you in my other videos in the channel. If you have any questions, feel free to leave a message in the comments, and I look forward to hearing from you. Take care and have a great weekend.